Hello, my name is Graham Perry, and I am Group 23. The problem confronted by this design is inefficient traffic lights. Traffic lights are often inefficient because they operate on a fixed timer for expected traffic patterns. This does not permit the system to account for changes in traffic flow on a case-by-case basis. This was the motivation for devising a model traffic light controller which could dynamically control lighting patterns. My first consideration was determining on what exact basis should the lights change. I settled on adapting the concept of busyness differently for traffic that is stopped or in motion. For traffic in motion, the program records how many cars pass by in a given time period. For stopped traffic, the program checks how many cars are waiting to go. Also of concern was how to measure the traffic. I considered different kinds of sensors to accomplish this, such as IR sensors or ultrasonic sensors. I settled on IR sensors because they were cheaper, smaller, and worked in the required range for my model. The other important hardware consideration was the microcontroller. An Arduino Uno was selected because it has an adequate number of digital and analog I/O pins, and it was easy to use. The other components were addressable LEDs and buttons for walk signals in emergency vehicles. As you can see, when traffic is flowing over the sensors, the lights do not change until it reaches a set maximum possible time. This is because more traffic is moving over the sensors in the green direction than is currently being held up over the sensors in the red direction. In this scenario, traffic is initially flowing, but then no more cars come after a time period. The sensors detect this and allow the light to change ahead of time to permit the traffic in the halted direction to move. Here, one of the walk signal buttons is pushed. This button triggers the crosswalk lights at the next opportunity for that direction, and extends the minimum time for the green light to give pedestrians time to cross. The crosswalk lights will flash red as the light gets close to changing. The system also optimizes how protected left turns are timed. If one side has a larger backup to turn left, that left will go on for longer, letting other traffic in the same direction advance sooner. These buttons control the emergency vehicle protocol to make it easier for emergency vehicles to go through the intersection. These buttons would most likely be either mounted on the vehicle or for a dedicated operator at the dispatch center. When the green button is pushed, all lights in the intersection turn red to prevent any traffic from going through. When the red button is pushed, the emergency is gone and normal traffic can resume. Many modifications would be needed to make this work in the real world, and it does not encompass all possible scenarios that could be encountered in real life. However, as a simplified model, it performs as expected and the underlying structure could be applied to more complex versions.